Hello students, once again welcome to Bholanath Academy. In this video students, we are going to see the reaction of alcohols due to breakage of carbon and oxygen bond in alcohol. Now in alcohol students, this is the formula ROH, where alkyl is containing carbon and oxygen of the hydroxyl. Between this there is a bond is there that is going to be break during the reaction students. So reaction due to the breakage of carbon and oxygen bond in alcohol. So students, here the carbon of the alkyl and oxygen of the hydroxyl bond will break during the reaction that we are going to see. So here students, when this bond will break students, when we are going to add the reagent, like first reagent students, the reaction with hydrogen halide. When you add hydrogen halide, that we can also show with H stands for hydrogen and X stands for halide. When you add hydrogen halide reagent in alcohol, the reaction will take place. During the reaction students, the carbon oxygen bond will break. That is why the reaction due to the breakage of carbon oxygen bond in alcohols. For that students, first reagent which we are going to add, we call as hydrogen halide. In shortcut we call as HX. Now students, when you see the order of the reactivity, which halide react with alcohol very fast, that is the order of the reactivity of hydrogen halide is hydrogen iodide. Halide may be chlorine, bromine and iodine. So only these three halide I have taken students. So the order of the reactivity of hydrogen halide is where hydrogen halide is more reactive as compared to hydrogen bromide as compared to hydrogen chloride. So reactivities go on decreasing from iodide to chlorine. So hydrogen halide is more reactive as compared to hydrogen bromide as compared to hydrogen chloride. Okay students, now we will see the reactivity of hydrogen chloride, which is very slow students. The reactivity, now what happens students when you add HCl in alcohol, so that we call as action. In board examination they may ask action of HCl on alcohols, what will happen? That is also called as hydrogen chloride. Since it is very slow students, for that students we are going to use Lucas reagent. If you are not adding Lucas reagent, there will be no reaction. So for that students we are going to use, so what is Lucas? It is a mixture of zinc chloride and HCl. Mixture of zinc chloride and HCl is called as Lucas reagent students. So here students, simple example I have taken students. Simple alcohol, that is, this is ethyl alcohol students. This is in common name we call as ethanol. This ethanol when react with HCl, action of HCl, this HCl will react with ethanol when there is a what reagent like zinc chloride, anhydrous zinc chloride plus HCl, and you have to heat it. Then these two reagents will react. Now what happens students, here the bond between carbon and here this bond will break. So OH of ethanol now combines with hydrogen of HCl and it will form water molecule. And what happens students, this will form CH3, CH2 and Cl. This is the formation of chloroethane, or you can say ethyl chloride. This is common name students, or you can say IBAC we call as chloroethane. So students, you have prepared the chloroethane from ethanol using Lucas reagent. This is Lucas reagent students. Zinc chloride HCl we call as Lucas reagent. So this way the reaction will take place because it's very slow reaction. That is why we have used Lucas reagent. Action of hydrogen bromide that we are showing with HBr. Now students, you have ethanol students. Simple example I have taken C2H5OH. Okay students, now what happens students when you add HBr? As compared to HCl students, it is more reactive, so only heating is required. Just heat it. What happens students, the carbon oxygen bond will break here. So OH of this ethanol react with hydrogen of HBr and it will form water molecule students. Now what happens students, it will form C2H5Br. There is a formation of bromoethane, or you can say ethyl bromide. In common name we call as ethyl bromide, or you can say bromoethane. In IBAC we call as, okay students, this is called as bromoethane. Now students, we will see the action of hydrogen iodide, which is very reactive students. What happens students, you just take ethanol, hydrogen iodide will react with ethanol. Small heating is required students. The OH of ethanol combines with hydrogen of the hydrogen iodide and it will form water molecules. Okay students, now here students, C2H5 now combines with iodine and it will form C2H5 ethyl iodide. You can say, and IBAC we can say iodoethane. So this way students, you can see the reagent here. Why it is called as students, yeah, hydrogen will be always positive and iodine will be negative. Understanding students? So this way it will form the ethyl iodide. Second reaction that we are showing with alcohol students reaction with phosphorus halide, that is we are showing with PEXN. Now reaction in that students we are going to see the reaction with phosphorus trichloride. Now students, what happens, you have alcohol C2H5 whereas this is alcohol students when react with phosphorus trichloride on heating students. Now what happens students, it will form, that is called as phosphorus acid, and there is a formation of ethyl chloride. Okay students, now what happens students, here since there is a 3 chlorine, so you have to make it thrice. Now here students, because now it is become 3 ethyl molecules, so you have to make it thrice here. This way students, you have to balance the reaction. So 3 molecules of alcohol, ethyl alcohol, react with 1 molecule of phosphorus trichloride, and just heat it, you will get 3 molecule of ethyl chloride and 1 molecule of phosphorus acid. So this way students, phosphorus trichloride, action of phosphorus trichloride on ethanol. In examination they may ask, so this way you have to write down the reaction. Now reaction with phosphorus pentachloride students, here also students, simple example I have taken. This is ethanol, phosphorus pentachloride. Now you have to just heat it students, heating is required, then only these two reactant will combine. So when you are using phosphorus pentachloride, there is a formation of phosphorus oxychloride. There is a formation of phosphorus oxychloride. Here students, phosphorus acid, here you are getting phosphorus oxychloride. Okay students, POCl3, chlorine, before chlorine you have oxygen, so we call it oxychloride, and this P stands for phosphorus, so phosphorus oxychloride you are getting. Along with students, you are getting C2H5Cl. Now here students, since you have 5 chloride molecules, if you want to balance it, you have to balance the reaction. For that students, HCl is also liberated. Here one of the hydrogen of ethanol combines with hydrogen of phosphorus pentachloride and form HCl. Okay students, this way now it is balanced, so there is a elimination of HCl and phosphorus oxychloride, and you are getting ethyl chloride. So this is very important students, reaction with phosphorus pentachloride. Dehydration of alcohols. Now very important students, the ease of dehydration of alcohol is like this students. Third degree alcohol, it is very easy to dehydrate third degree alcohol as compared to second degree alcohol as compared to first degree alcohol. Dehydration of tertiary alcohol, it takes place very easily as compared to secondary alcohol as compared to primary alcohols. Understanding students? So this is very important students. Now we will see the first degree alcohol, how first degree alcohol or primary alcohol is dehydrated with heating with 95% sulfuric acid you have to take, and you have to just heat it. So here students, the percentage of sulfuric acid is very important. Primary alcohol, it is very difficult to dehydrate, that is why you have to take 95% sulfuric acid. Okay students, so simple example students I have taken here ethanol. Take 95% sulfuric acid, 95% sulfuric acid if you are taking, and if you heat it, what happens students, now hydroxyl, there is a breakage, this bond will break, carbon oxygen bond will break, so OH of this carbon now combines with hydrogen of this carbon, and it will form, there is elimination of water molecules. This alcohol will eliminate water molecule like this, and this bond, one electron will come here and it will form carbon double bond. Okay students, so this way students, you are getting ethene. So from ethanol you have converted ethene, there is a formation of ethene. Understanding students? So ethanol is now it is converted into ethene. So alkene has been formed students on dehydration of primary. This is first degree alcohol students, where OH is attached to the first degree carbon. So primary alcohol is dehydrated on heating. This is the symbol of heating students, with 95% sulfuric acid. There is a elimination of water molecule. And there is a formation of ethene. So students, this way dehydration is take place. Primary alcohol is dehydrated and it will gives you ethene. Want to dehydrate secondary alcohol. This is secondary alcohol. A secondary alcohol is dehydrated by heating with 60%. Here 60% sulfuric acid students you have to use if the alcohol is secondary alcohol, a second degree alcohol you can say. So second degree alcohols, how you are going to, I am taking the alcohol students. This is the secondary alcohol. This carbon is attached to these two carbon, and this carbon is attached by hydroxyl group. So this alcohol we called as secondary alcohol students. Now fill the valency with hydrogen. Carbon is tetravalent, so this way you have to fill the valency. So this is the propane 2OL. This is the free carbon containing alcohol students, so we call it as carbon number 2. There is a alcohol OH hydroxyl group is attached, so we call as, this is second degree alcohol students. On dehydration students, you have to use 60%. Since it is second degree alcohol students, you have to use 60% sulfuric acid. 60% sulfuric acid is very important here. So just heat it. What happens students, here there is a breakage between carbon and oxygen bond here students. So here OH hydroxyl of this carbon now combines with hydrogen. It may be combined this side or this side, and there is elimination of water molecules. Dehydration will take place. Elimination of water molecule is nothing but dehydration. And what happens, students? One electron will come from here, and it will form carbon-carbon double bond, and this carbon will be as it is. So here 3 hydrogen is there, students, so CS3, and 1 hydrogen is already there here, and it will form the propane. So propane 2OL is converted into propane. Okay, students. So this way, students, second degree alcohol is dehydrated by using 60% sulfuric acid, and it is converted into alkene, that is propane 2OL will convert into propane. Second example that we are going to take, that is called as butane 2OL. But stands for 4 carbon. Since we are talking about second degree alcohol, students, here the hydroxyl group, if it is attached to this carbon. Okay, students, carbon is what? Tetravalent. So this way, students, you have to fill the valency of carbon, fill the valency with hydrogen. So students, please pay attention, this is very important. Now what happens, students, because since it is second degree alcohol, that is, so by observing these two, you can to know it is what? Second degree alcohol. Now if it is second degree alcohol, students, the sulfuric acid percentage will be 60% sulfuric acid you have to take. If you want to remove the water molecule from this alcohol, students, you have to take 60% sulfuric acid. Now you have to heat it, students. Now what happens, students? Now the carbon and oxygen bond will break here, students. Now OH of this secondary alcohol will combines with hydrogen, whether it is will take the hydrogen, this hydrogen or this hydrogen. Understanding, students? So it will form 2 substituent, students. There will be the formation of 2 types of butane. One will be, since if water molecule is coming from here, if water molecule OH combines with this hydrogen, you are getting carbon double bond. If it is combining with this fashion, students, and you are getting CS3, and this side you are getting CS3. Understanding, students? So you are getting here the carbon-carbon double bond is present between these 2 carbon. So this product will be major product, students. And students, if it is coming from this carbon, students, you are getting carbon-carbon double bond here. If it is combined with this hydrogen, so you are getting but1En, which is minor. So this takes place because of the Setzeff rule. Okay, students, here the more methyl groups are available, students. That is why this is major product. According to Setzeff rule, you are getting but2En will be the major product, and but1En will be the minor product, according to Setzeff. So highly substituted methyl group, here you are getting 2 methyl group. So where will be more methyl group, that product will be major product, and here you are getting only 1 methyl group, CS3, so that will be the minor. Understanding, students? This is very important, students. Now one more dehydration that we are going to take, students, that is called as third degree alcohols. How third degree alcohol is very easily dehydrated by heating with 20% sulfuric acid. Only 20% sulfuric acid is required if you want to dehydrate third degree alcohol. Now, students, very simple example here, students, that we are going to take third degree alcohol is carbon. OH is attached to that carbon. This carbon is attached by 3 carbon. So students, this is the, since it is third degree carbon, so it should be surrounded by 3 carbon. So CS3, CS3. So students, you can name like this, students. So 2 methyl, the third degree alcohol is 2 methyl propane 2OL. So third degree alcohol I have taken. The example is, this example we have taken 2 methyl propane 2OL. This is the alcohol, students. Now this alcohol, if you want to dehydrate, students, only 20%, because very easily you can dehydrate this alcohol, students, 20% alcohol, and just heat it. So what happens, students? There is a removal of water molecules. The bond between this carbon will break, and this hydrogen OH will combine with this, and there is a formation of compound of ethane like this. So this way, students, you have got the formation of ethene molecules. So here, students, this is nothing but, when you start the counting, students, 1 2 3, so you add carbon number 2, there is a methyl group. So which type of ethene, students, you are getting, which type of alkene, students? It is 2 methyl propane. You have got, students. So this is type of alkene. So this way, students, alcohol is converted into alkene, corresponding alkene. So 4 carbon containing alcohol is converted into 4 carbon containing alkene. So this way, students, dehydration is taking place. Students, how the oxidation of alcohol is taking place, students? So first oxidation of primary alcohols that we are going to see, students. Primary alcohol, students, simple example is ethanol. Now, students, in presence of K2Cr oxidizing agent, we are taken here, students, K2Cr2O7. plus sulfuric acid, dilute sulfuric acid will produce nascent oxygen. It will produce nascent oxygen. This nascent oxygen is very reactive students. It will obstruct the hydrogen like this students, and there is a formation of water molecules. And what happens students, one bond will come and there is a carbon-carbon double bond, and your methyl group will be as it is. It is converted into ethanol. So students, oxidation of ethanol is converted into ethanol. If you do further oxidation students, again if you are using the nascent oxygen, now again what happens students, this oxygen will combines with this ethanol. Now there will be further oxidation if you are taking students. Now it will combines, this oxygen will now combines with ethanol and you are getting ethanoic acid. CH3 will be as it is, and this oxygen will combine here and from OH, and so there is a formation of ethanoic acid. Understand students? So ethanol on oxidation, it will produce you ethanoic acid. So first ethanol will convert into ethanol. On further oxidation students, it will convert into ethanoic acid. So this way students, you can convert first degree alcohol into corresponding carboxylic acid. Oxidation of second degree alcohol. If you are taking second degree alcohol students, you can take propane 2L. The OH is attached to second degree carbon is called as second degree alcohol. Okay students, so this is second degree carbon to which OH is attached, so it is called as second degree alcohol. So propane 2OL will be the second degree alcohol. When you do the oxidation with nascent oxygen, combines with the help of the K2Cr2O7 and dilutes sulfuric acid. So what happens students, there is elimination of water molecules. Hydrogen, this hydrogen combines with this oxygen and it will form the water. And what happens students, there is a formation of carbon-carbon double bond with oxygen. So this way students, it is converted into ketone. So which type of ketone? It is nothing but acetone. We also call as what? Acetone. So propane 2OL is converted into acetone, or you can say in IBC you can say propane non. This is nothing but what? Propanone. Understanding? So this way students, second degree alcohol converted into acetone, that is ketone. It will convert into ketone. Now students, oxidation of third degree alcohol. How third degree alcohol is converted students? When the hydroxyl group is attached to the third degree carbon, we call as third degree alcohol. So this is structure students, third degree alcohol I have taken. The third degree alcohol students, in third degree alcohol you have taken 2-methyl propane 2OL. 2-methyl propane 2OL will be the third degree alcohol students. Why it is third degree students? OH is attached to third degree carbon. So this type of alcohol we call as third degree alcohol. You have to use chromic acid. You have to use KMNO4. This oxidizing agent you have to use students. So what happens students? They will produce nascent oxygen. Now they will form the water molecules like this, and it will convert into 2-methyl propane. Okay students? So there is a formation of, want to further oxidize this 2-methyl propane students. This is 2-methyl propane. On further oxidation with CrO3 and just heat it, or you can use KMNO4. So what happens students? It will convert, it will gives you carbon dioxide, water, and so students, here the carbon, it will go combines, it will form carbon dioxide, and hydrogen will form water molecules, and one of the oxygen will combines, it will form acetone. You are getting ketone, or you can also call as propanone. Okay students, so IBAC you can say propanone, and commonly we call as what? Acetone. So this way students, you have got the acetone. The oxidation of alcohols with copper metals. In general students, suppose you have first degree alcohol, OH is attached to the first degree carbon, we call as first degree alcohol. Now first degree alcohol students, when you add copper and you have to heat 573 Kelvin, so oxidation will take place. There is a removal of hydrogen. So what happens students? It will convert into, so here the one of the hydrogen will remove, and here the from one of the hydrogen will remove, and it will form RCHO. There is a CH2OH is converted into aldehyde. In examinations, they may ask action of copper on primary alcohols. The primary alcohols will always gives you aldehyde. Now what happens students, when OH is attached to the second degree? If you are taking second degree alcohol students, where OH is attached to the that carbon which is attached to 2 alkyl group. This is second degree alcohol students. Action of copper metal on second degree alcohol, copper, and 573 Kelvin, the oxidation will take place. Now what happens students? Here the OH, this bond will break, these two hydrogen will eliminated, and there is a formation of ketone. Understanding? So there is a removal of these two hydrogen, and it will form the ketone. Removal of hydrogen is called as oxidation, students. So this way second degree alcohol converted into ketone. Okay, students. Now, students, we are going to see the third degree alcohol. Third degree alcohol, students, carbon which is surrounded by CH3, 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 to which this is third degree carbon to which OH is attached. That is your third degree alcohol, students. What happens, students, when you add copper and just heat it at 573 Kelvin? Heating is required. So there is a dehydration will take place here. Third degree alcohol will dehydrated and it will form alkene. So OH combines with hydrogen. Any one of the hydrogen you can take from here or here, and it will form. Suppose I am taking from here, so it will form carbon-carbon double bond, and this methyl group will be as it is. So this way, students, it will form, or you can say 1, 2, 3 at 2-methyl. This type of alkene 2-methyl propene. This way, students, we have seen the oxidation of alcohols, whether it is primary, secondary or tertiary. In board examination, you have to write like this. You will get the full marks. Reaction is very important, students, in board examination. So this way, students, you have to represent the reaction. If you like my video, please share it, subscribe it. Thank you very much. Have a nice day. God bless you.